guys, Miss Kulkarni here. So, let's hope that we are working on organic synthesis and we were fortunately making some progress and we synthesize a chiral compound. The next step is, how do you find out the identity of the compound? What did you make? And how pure is the compound? And these things are not as easy for the chiral compounds, but there is something which helps us a lot. So, physical properties for all the stereoisomers, for all the enantiomers which you're having, they will be having almost identical physical properties. So that's a tough thing. You don't know whether you got the correct enantiomer. But there is something which is unique to that particular enantiomer. What is it? It is how that interacts with plane polarized light. And now what is plane polarized light? So this is like a vector. In physics we talk about vector, and light travels, oscillates in all directions. But when light travels only in one single plane, that we call as plane polarized light. How is it produced? When light is passed through an equipment which is called polarimeter, that can give rise to a plane polarized light. And we will go through some figures to explain it better. So what is a polarimeter? It is an instrument, equipment that will allow the polarized light to travel. And the sample tube will be containing the pure organic compound, chiral compound, which you and me, we synthesized it together. Alright, so second thing to keep in mind is polarimeter also gives you the measurement of the degree by which the plane polarized light is bent or it is tilted. Let's look at the figure to make it easy. So for any molecule which is a chiral molecule, that means it does not have a chiral center, not a single one. Then if that sample is kept in polarimeter, what will happen? What do you expect? Nothing will happen. The plane will not change, and we call that as optically inactive compound. Look at the figure here. That's the light source which we got over here. This is the light which is oscillating in all directions. That's the polarizer, and this is the plane which is plane polarized light. If the sample tube which we got over here is containing a sample of our achiral compound, what happens to the plane? Nothing. There is no change. So that tells you whether you got your compound or not. So if you put your compound and there is no deflection, no change in plane polarized light, you did not get that chiral compound properly. If you have a chiral compound, what will happen now? The plane polarized light will be rotated through an angle, and we use the angle, that symbol, as alpha for that. This is measured in degrees. So the compound is called as optically active, and that means you probably have a compound with some chiral centers. So look at again same thing, light source is here, that's our ordinary light. This is the polarizer, that's our plane of polarized light. And look at in sample tube what happens. The plane polarized light is getting deflected. The plane is deflected through an angle which is kind of, we denote it here as alpha. And there is of course analyzer which can measure that angle. So this is one of the simple method to find out whether we have a chiral compound or not. Now you will say, what is the big deal about having a deflection? How do you know that you got the same compound? Here is the deal. That angle of rotation is specific for the nature of the compound. And of course, it also depends upon the concentration of your chiral compound. There's a formula we'll talk about afterwards. But pretty much for a specific compound, the angle alpha, the angle of rotation, should be always constant. There's also one more thing. The plane polarized light can be rotated either in clockwise or anti-clockwise direction. If it's clockwise, we also use the word dextro-rotatory. Dextro means right, to the right side, like the hand of the clock goes to the right when we say clockwise. We also label that as D, or it is plus positive if it is rotated to the dextro or it's clockwise. If the rotation is counterclockwise, opposite in the reverse direction as the clock goes, then we call it levo. The levo word stands for left and is labeled as L or also as negative. More and more commonly, you will see probably positive and negative signs for indicating which way it is deflected. So both positive and negative and also the value of that angle gives you some more information about the chiral stereocenter. What if we have a mixture of two enantiomers? What will happen? In this case, the plain polarized light is going to show no deflection. Do you know why? If one of the enantiomers shows rotation clockwise direction, let's say maybe it's positive 5 degrees, then the other one is going to show exactly same rotation in anti-clockwise, or it will be negative 5 degrees. So they will cancel out and we won't see any rotation at all. So the racemic mixture will not really tell you whether you got the desired compound or not. Of course, it needs to have the equal amounts of two enantiomers to make the mixture racemic. If it's one less and other one is more, it won't be perfectly racemic mixture. And now you know why it will be optically inactive. So let's go back to our specific rotation angle. Just as I mentioned earlier, this angle will be a constant, a particular value for a specific compound. So you can say it's a physical constant for a chiral compound. There is one more thing. It is for the amount of that particular chiral compound. Remember, we said it is the specific compound and also its concentration. So this means for a particular chiral compound at a particular concentration, this physical constant, specific rotation value, or what we call as alpha, will be always same. It will be constant. And here is the calculation. So if you get the observed rotation value from the polarimeter, if you know the length of your tube in which sample is kept, and if you find out the concentration, you can find out using this formula what is the specific rotation. And if it matches with the value in literature for that compound, hey, you made the compound and it is fairly pure. So what did you learn in this video? You learned a little bit about the structure of polarimeter. You also figured out what is plain polarized light, how it differs for optically active and inactive compounds, whether the plane is rotated or not rotated. We also found out about specific rotation, how to calculate that using formula, what is its significance, and also we found that this is a physical constant and how it can help us to determine the identity and also the purity level of a chiral compound that we synthesize. And also keep in mind, there are more analytical methods like mass spec or NMR that can be used to identify the substance and also confirm the purity. But this one is specifically for chiral centers. So guys, I hope you enjoyed the video and I'll see you again in next video. Until then, bye bye.